Look at this image. This is a lifestyle magazine cover. The Chinese text, English text, layout, and main subject are all generated in one pass. And this one is a three-part brand poster. The title, character, and brand name are placed exactly where we specify them. This one uses the same composition but with 3 different color palettes. We only changed a few hex color values, and the entire atmosphere became completely different. And this one is a 2K skincare product poster. The hair strands, text, and color tone are all very stable. So what do these images have in common? They were all generated by the same open source model, and their prompts are not natural language. They are JSON. What is this model called? It's called Ideogram 4. It is the first open-weight text-to-image model released by Ideogram, with a total of 9.3 billion parameters. It was trained completely from scratch, not fine. Tuned from any existing model, its core goal is very simple. Make the model truly able to write text inside images, write it accurately, and write it clearly. Let's first talk about the core technology behind the model. Ideogram 4 uses a fully single-stream DiT, which means diffusion transformer. Ideogram 4 directly combines text tokens and image tokens into one sequence and processes them through a 34-layer transformer. This is why its text rendering is so strong from the very beginning. Text information and image information exist in the same space and influence each other. It is not generating the image first and then overlaying text afterward. The text encoder is also different. It does not use traditional clip. It uses Qwen3-VL, which is a large vision language model. There is also a special architectural design called Asymmetric CFG. In traditional diffusion models, the unconditional branch usually replaces the prompt with an empty string and then runs the model twice. Ideogram is different. In its unconditional branch, it directly removes all text tokens and only runs the image tokens. This is why inside ComfyUI, there are 2 diffusion model files, one with text conditioning and one completely without text. You'll also notice that the official leaderboards and benchmark numbers they released look very impressive. Of course, whether it is really as strong as the official claims is something we can only know after testing. Right now, ComfyUI officially supports this model natively, and they have also published a blog post about it. You can go take a look for easier demonstration. I also built the workflow on Running Hub. In the ComfyUI space, Running Hub is a really great online workflow platform because whenever new models or new extensions appear, it usually follows up very quickly. Running Hub also provides an online community platform for ComfyUI creators, where you can find a lot of creative inspiration and example workflows. First, let's talk about the model files. There are mainly 4 files used here. The first is the main model, and there are actually 2 of them. One is unconditional and one is conditional. Then we have the text encoder, which uses Qwen3-VL. Finally, we have the VAE, and here we use the FluxPoint2 VAE. Let's emphasize again why there are 2 diffusion models. When we talked about the architecture earlier, we said that Ideogram 4's unconditional branch removes all text tokens. In other words, inference with text conditions and inference without text conditions follow different computation paths. So the official release simply split them into 2 sets of weights and stored them separately. During inference, ComfyUI nodes will call them automatically. You don't need to switch anything manually. Just place the 2 files side by side. Now let's briefly look at the workflow. The overall structure from left to right is divided into 4 areas: model loading, text encoding, sampling, and decoding. It looks very similar to a Flux workflow layout, but there are a few differences. Let's go through them one by one. For the main model, we download 2 files, one with text conditioning and one without text conditioning. These 2 are connected to the following nodes separately. For the text encoder, we use Qwen3-VL. Make sure the node type is selected correctly. Don't just choose randomly. Next is the prompt input, which is the most important part. This is also where Ideogram 4 differs from other models. The prompt node supports 3 types of input. The first is direct natural language input. The second is direct input using a standard JSON format file. This is the best performing method, and it is also the format the model was originally trained on. Later, all of our JSON prompts basically follow this route. The third method is using magic prompt. We enter a natural language description, then use a prompt generator to convert it into JSON format. The result is usually somewhere between the first and second methods, but the barrier to entry becomes much lower. So there is a separate function group for this, and by default, it is in bypass mode. The full process of this group of nodes works like this. In the user prompt, you write one natural language sentence. For example, a beautiful woman holding coffee with a sunlit cafe in the background. In the system prompt, there is already a complete prompt engineering instruction built in, telling the model how to generate a complete JSON prompt. After these two pieces of text are combined, they enter the text generate node. This node uses a local Gemma 4 model. After reading your description, it automatically converts your natural language into JSON format. The key model here is also a new feature recently supported by ComfyUI. You can download this model from ComfyUI's Hugging Face repository and place it inside your Texty Encoders folder. That's all you need to do. Now let's talk about sampling. My sampling setup here is a little different from the official one. I use the Euler sampler since the original paper says Ideogram 4. Was trained with flow matching, the corresponding sampler is Euler, so I just use that directly. The official release also provides 3 sampling presets, mainly with different step counts. The first one is 48 steps, and this is what I recommend using when you want to generate final images. There is also a 20-step version, which is a balance between speed and quality. The third one is 12 steps, which is for fast preview. Finally, we decode, and then we get a very beautiful image. The biggest feature of this image is precise control. So why can it be controlled precisely? Because the JSON prompt has a classic 3-part structure. The first part is called high-level description. It uses 1 or 2 sentences to describe what the overall image is about. The second part is called style description. This describes the style, lighting, medium, and global color palette. The third part is compositional deconstruction. This breaks down every specific element, including its position and detailed appearance. All of that can be written here. Once we understand this workflow, we can move into testing. First, let's feel the difference between natural language prompts and JSON prompts when used with this model. We'll describe the same image, but generate it once with natural language and once with a JSON prompt. First, let's look at the natural language version. This describes a woman reading a book in sunlight with a line of text at the top of the whole image. You can see that the overall result is still very beautiful. Now let's look at the JSON prompt. For the same content, I now use a complete 3-part JSON structure. Inside it, the background character, title text, and bottom slogan are described separately. Each element has its own independent definition, including position coordinates and colors. You'll notice that our title is clearly placed at the top. The character is sitting in the garden, and the lighting, outfit, and expression all match the description. The slogan at the bottom is also generated accurately. This is the value of JSON prompts. The more accurately you describe things, the more the model can do. This can often create a misunderstanding. Some people may say, I feel like the natural language version looks prettier. That is only from the visual perspective. What we really want to explain here is precise control. Next, let's look at text rendering. We'll create a floral lifestyle magazine cover. In the upper Zan left corner, we place the English magazine title. Below that, there are large Chinese characters reading Shengfang. Further below is the English subtitle. On the right side, there is a girl holding peonies. At the bottom is the Chinese issue information. Look at the result. The Chinese and English magazine titles are both very clear. The Chinese text, Shengfang, is also generated. The English subtitle in full bloom is placed in the correct position. At the bottom, Spring Qwen Summer 2020 Zen 6 issue is also clear and readable. This kind of precise control would have been almost unimaginable 1 year ago. Back then, one of the biggest pain points for OpenZan source models was generating accurate text in the correct position. Next, let's look at layout control here. We use BBox coordinates to force each element to land in a specified position. This image is a 3-part herbal tea poster. At the top is the brand name. In the middle is the main character. At the bottom are the product name and the Chinese subtitle. For every text element and the character, we provide accurate BBox positioning. The format is top left corner and bottom right corner with the range from 0 to 1000. Now look at the result. The brand name sits firmly at the top. The character stays in the middle area and does not cross the boundary. The product name, Chinese label, and decorative text at the very bottom are all in the correct positions. Where is the value of this ability? For designers, the hardest part is not generating a good-looking image. The real headache is making sure every element inside the image appears exactly where you want it. Next, let's look at color palette control, meaning 3 different atmospheres using the same composition. This test is very simple. The character description is exactly the same, and the composition is exactly the same. We only change the color values inside the JSON. Let's see how much the atmosphere can change after switching a few colors. The first palette is called Warm Milk Coffee Tones. The palette uses cream as the base, caramel as the accent, and dark brown for weight. The whole image moves toward a warm tone, with a bit of coffee texture and a lazy afternoon feeling. The second palette is called Dreamy Lavender. The palette changes to light purple and medium purple, with a small amount of golden yellow as an accent. Now look at the image. The whole atmosphere changes. With the same character description, it shifts from a coffee shop feeling to a lavender field, and the lighting also gains a sunset backlight quality. The third palette is called Fresh Japanese Cherry Blossom Style. The palette is changed to pink, white, cherry blossom pink, and mint green. The overall result becomes completely different, clear, quiet, and like a Japanese-style portrait shoot. Finally, let's do a comprehensive stress test here. We set the resolution to 2048 by 2048. Actually, all the images I generated are 2048 by 2048. This image is also a promotional visual for a skincare brand. It contains quite a lot of elements, including a large title, an English subtitle, the main character, the English name of the product line, a Chinese subtitle, and decorative patterns across the overall background. Now let's look at the generated result. The logo is firmly placed at the top and the proportions and spacing are fine. The main character is clear. The hair strands and skin look more stable at 2K. The product name, Chinese title, and decorative copy at the bottom are layered downward without confusion. This is a snapshot of the model's overall capability: text rendering, layout control, color palette control, and high resolution all running together in one image, and the model can handle it. Finally, let's summarize Ideogram. 4 is most suitable for design-related tasks: brand posters, product promotion visuals, and images where layout needs precise control are its home field. If what you want to make is realistic portrait photography, landscape images, or cinematic shots, I don't think those are its strengths. Although we have been praising this model, there is one thing we have to admit. The image quality it generates is a little blurry. It is not as clear, transparent, or bright as images generated by models like Z-Image or Qwen3-VL. It has a slightly hazy feeling. Also, we think the biggest barrier to using this model is writing JSON prompts. Even if you use the prompt generator inside our workflow, because the local model's capability is limited, the generated result is not especially good. So I recommend using commercial models such as Gemini, Claude, or ChatGPT. The results will usually be better. Finally, let's talk about commercial use. Ideogram is open source, but it uses a non-commercial license. That means personal learning and research are fine. But if you want to use it to make money, that is not allowed. And one last very important issue. Some people may ask, why are the images I generate with the official ComfyUI workflow so low quality? Pay attention here. There is a CFG value set to 7.0. Try lowering it to 4.0 or 3.0, and the generated quality will become much better. Alright, that's all for today. So what are you waiting for? Go try it yourself. Follow me and become someone who truly understands AI.